Next, we have finding the absolute value of imaginary number. This is also called finding the modulus. Okay. A complex number can be referred to as z. The absolute value of a complex number is just the distance from 0. Okay. So when you have a number, a complex number, a plus bi, the definition of absolute value is the distance from 0. It's no different if you are on a number line or if you are in a plane. And so what we are looking for is that distance. Well, if I draw in a right triangle, this distance is a, this distance is b, a squared plus b squared equals c squared. I can go through, I can find my distance. So it's just the square root of a squared plus b squared. Okay, and it's always going to be positive. So, excuse me, 4 plus 3i, just a rough sketch. 4 plus 3i. If you notice this quickly, this is a 3, 4, 5 triangle. I don't even have to do any math. Or you can say the square root of 4 squared plus 3 squared, or 16 plus 9, or the square root of 25, which is 5. But if you remember your Pythagorean triples along the way, some of these will save, the Pythagorean triples will save you a little bit of time. Okay, absolute value, again, this is also called the modulus, all right, because shortly we're going to be changing these to polar form. So, absolute value of negative 2 plus I. So negative 2 plus 1i. This is not a Pythagorean triple. So I have the square root of negative 2 squared plus 1 squared, or the square root of 4 plus 1, or the square root of 5. So the distance that this is from the origin is the square root of 5. Or it's the modulus of negative 2 plus I is the square root of 5.